Let's go, let's go. Nikki, you wanna present too? Shall we do it together? Hello. Okay. Hello. We're very loud. There we go. It's better. Let's go higher here. Yeah. Okay. Bye. All right. Shall we kick this? Welcome, everyone. We have some visitors. Mine? Yes. We have some visitors still arriving here at V2 in Rotterdam, and we are we online? Yeah, sure. And we're streaming, hopefully recording as well. And this is this is our meetup number 16 here in V2. So thank you, V2, for hosting us always. Thank you, everybody that made it here with less than optimum weather. And we have we're basically, this is the first edition of our 2026 meetups. We're gonna have a couple of presentations, short ones, and then hopefully about an hour or so for jams towards the end. We had a week of like an intense week for live coding events. We had a carnival algo rave in Eindhoven just this weekend, and coming up on Friday on the 20th in Amsterdam, Vondelbunker, we have another algo rave. So more about that later maybe, but for now, maybe who's going to start presenting so that I can pass this microphone to the presenter? Yeah, Johan? Okay. Okay, we're going to connect Johan.
Yes. Yeah. Okay. Yes? All right. Well, hello, everybody. I'm going to put it maybe here. Else I will look that way when I talk to you, so that's a little bit strange. So I'm going to present maybe 10 minutes or so about something that I'm working on right now, and it's a bass sound that is usually used, many times used in jungle music. I would like to try make more jungle-like music in live coding. So here we go.
Presenting some?
Okay. Start it. So for live coding, I use Super Collider. And Super Collider, I can show you the help window. And about Super Collider, I use this version. Super Collider is, yeah, what is it? It's not just a simple program. It's an editor, and it has two processes in your computer, one making music and one he didn't like it. And one sending commands to that process to make music. And making music is very simple, simple in Super Collider, and it's starting a little process in the memory of the computer, and they call that a synth, like from the word synthesizer. And a synth has a definition, and the definition is some pure programming code. And you also can send the synth parameters, maybe like the frequency that he has to play or the panning left and right. So you have the code that you make once and then it sort of stays the same. But you can start many synths with the same code but different parameters. And if you do that in a timely manner, then you can make music with it. So that's, in a nutshell, Super Collider. So I'm trying to make a Reese bass with for making jungle music. Now, normally a bass is just a low note. You know, of course, bass guitar makes a low sound. The Reese bass is its characteristic, as I have learned so far, that it has a few low notes which are differencing in frequency just a little bit. And they are played together. And then they start interfering with each other in the speakers of your sound installation. And then they make the sound interesting. But also it has a disadvantage because the low notes, if you have one note of 100 hertz and you let it fight with another note of 110 hertz, then they will cancel out many of their frequencies. Like you throw two stones in the pond and you see the waves approaching each other, and then some of the waves cancel each other out. And that will also happen with the Reese bass. So if you want to make really low, sub-loud bass sounds, then you cannot use the Reese bass. Then you have to use a different algorithm. But in the case of jungle music, usually the bass is like a Reese bass. So now I will try to explain the code that I have so far and the plans that I have to go maybe further. So this part of the code is the definition, the synth-F. So this defines the code for one little synth that will make music in the in my memory. It gets a few arguments, like the frequency, of course, at what frequency it should make its sound. The velocity, that is a number from 0 to 1, which says how, how loud or how, you can do anything with this number. The gate, it will go from 0 to 1 when the note has to stop again. And when that happens, it will stop and the process in your computer will disappear. And the sustain is a number of seconds that the note will last. And it's handy in the synth-F if you know beforehand how long the note will last. And I use it here in a sequencing language, so every note that I'm playing, I know for sure how long I will let it last, because the sequencer is also the one who will make the gate close. So, even kijken hoor. And you can have variables in the code here, like the signal that I'm making, some detuning. You can have I have an envelope and I have unison on 11 at this moment. So that means that I will make 11 saw waves at the same time, and they differ a little bit in frequency, and they are detuned a little bit. And it's also that the middle one is the loudest, and then 5 on the right, 5 on the left, they are slowly getting less loud. And all that audio is summed, and that will be the resulting sound. So here I get the detune parameter. I get it here in this variable. And then here I make the signal. So I collect 11 signals here, and between these brackets the signal is made, and the signal is a saw wave from a frequency, and the detuning defines how much this saw wave will have a different frequency than the middle one. And the rest is just some amplitude and the phase where it starts. So, and then the 11 saw waves, I sum them up, and then I put it through a low-pass filter, which is also, well, the standard low-pass frequency is 300 hertz, but it's a parameter of the synth, so you could, in your sequencing software, make it a little higher or lower or whatever you want at the moment that you're using it. Then you can pan it to the left or the right, and there's a high-pass filter so that this bass will not interfere too much with the kick drum. Because in the bass area, it's always, that's something that I'm also working on now, that it has to sound good all together. So if you, in my music, I hear a lot of times that the bass is interfering with the kick. And if I then give the bass a high-pass filter, and I put it around 80 hertz or so, then I suddenly can hear my kick coming through in the mix. So then I know, this is what I have to do, or else I'm going to kill my own kick with my bass, or the other way around. So I give the kick a low-pass filter, and then a lot higher in the frequency, I give it some more signal back, but not in the bass area. And this last line is the envelope. So the sound starts, and then the sustain level is 1. It goes like this. And then when the gate is shut, it releases very quickly so that the next bass note can be played. And yeah, this is the way in Superglider that you can design your own sound. And this Varso, it gives you one sound wave. And if you look here in the help at the UGens, I have to make it a little bigger, I guess. UGens, and then the generators, deterministic generators. You have blips, you have FM, frequency modulation, sine waves. You have lots and lots and lots of ways to generate audio in all kinds of different waveforms. And they will all have their characteristic sounds. So when you activate the definition, then you get feedback here, like, oh, a synth has been shot into the server. If you make a mistake, then this mistake will pop up here, and then you have to correct it, because else it won't. Okay, enough. So now I set some tempo here, like this. And here I start 2 effects. So I have one tank, which is a reverb, and I have a comb filter, which has a delay, and it will repeat sound that you put in there, and it will send it a little bit to the reverb afterwards. And now I'm not sure. I'm going to do the volume a little bit lower, because last weekend I started something with a high volume, and it was really high. So I'm sending. Yeah. So in this sequencing language that I have here, I made it myself, and it is influenced by a well-known language called tidal cycles. But I like to do everything in Super Collider in just one system and not install many other things, just one. So I programmed it myself, and here I have this key, which is the degree playing the notes. So this is the degree in the scale of notes that are played. This one is a rest. A -2 is it's now in the major scale, is a lower note, and this is the third note of the scale, and it lasts a bit longer than the other two. So, and you can change the octave and make it change again. You can make it faster, of course. You can do many things. Oops. You can do many things. So now I'm just going to fool around a bit to get some sound, maybe what could be interesting. I prepared a little drum beat. Yeah, that's also, I try to make some kind of a jungle-like beat. So maybe it fits with this together. So like this. And yeah, in Super Collider you can also work with samples, of course. So I sampled on my work, there was a printer printing, and I thought, that's a nice sound. So that was a Brother printer. So I sampled it and chopped that up, and then you can hear a printer playing somewhere. I put it a little louder. Or maybe this. Let's listen to it. It's really it's not loud enough yet. That's also something that I'm struggling with, the balance between the different things. Like if you make a sound with Super Collider and you calculate the audio, usually that sound is much louder than something that you recorded as a sample. Samples I have to push up in volume a lot to make them just a little bit in balance with the rest. And yeah, so this one I can easily put on the 9 because it's, oops. I have to take you away. So it will become a little bit louder now. And now I have to get it out of the solo so that the rest can be heard again. There's one more thing. I was walking a trail last time, and I had to go through a cattle fence, and I opened the fence and I heard squeak. So I thought that was too nice to leave behind also. So I recorded it, and I put it here through a grain buff synth. So that's something you can also do in Super Collider. You can make a sample and then use it differently and have pointers in the sample going various ways. And I like that very much to do that. So I put the fence in there, and then there it goes. And then also the gain thing. So in this line here is a control signal, and that control signal makes a signal which will be the position in the sample that I'm grain buffing, and then I can make some adjustments to that while the synth is playing. Anyway, this way, I am working constantly, making sounds, getting inspired by other sounds, and yeah, that's what I wanted to share with you today. I think, yeah, that's it. Maybe there's questions.
Yes, so we have another microphone here for questions. Maybe you keep that, Johan. So are there any questions for Johan before we move on to the next presentation? Anyone? No? Yes.
Yeah. Did you, Johan, try to master your sounds, like which you recorded? Because I think when you play the recorded sounds like printer or something, did you master them, like to limit it or like push it up?
I did. I put them in Audacity and I normalized the volume. Yes. So
yeah, and it's still
yeah.
my God.
It's strange that the energy content is much less than a pure sine wave or a pure square wave, which is so much louder than things that come from the nature around us. Yeah.
Okay.
Yeah.
That's because those sounds are complex, but we can talk about this some other time.
Yes, I would teach me.
Any other questions for Johan? Yes.
Okay, I have a question, and it's maybe I didn't understand very much what was going on there, so that's why I have that question. And my question is, like, if the samples are also moved by BPM that you set on your kind of like settings at the beginning. If it's working as a synthesizer, basically, also with the samples, or samples are separate, like in settings, basically, or like in a rhythm. The rhythm is the question. Yeah.
Well, that you can arrange for yourself, basically, because in my system I have one built-in synth. It's called PlayBuff, and it will play a sample for you. And if you play a sample and you give the synth a frequency argument, well, what can it do with a frequency argument? I mean, the sample is what it is, and it just plays the sample. So the frequency arguments could not be used then. So in that PlayBuff, I use the frequency argument to play the sample higher or lower. So you can play a tune using a sample in the pitch. Not. Oh yes, it will go. It will go faster too. If I up the BPM, then because I sequenced the buffer, I can show you here still. Yes. So this brother printer sample, I chopped it in about 8 WAV files, small WAV files, and these are the buffers here, like number 1, number 4, number 3, and so here I sample. In one cycle, it plays these buffers. So here's a rest. This is alternated between the first and the second cycle. This is the third buffer. This is the third buffer within the time of the others, you know, twice as fast. And this is the fifth buffer. And so if I up the BPM, then this cycle will be shorter, and so the samples will be played faster. Yeah, that was your question, right? Yeah, yeah. Yeah, that will surely happen, yeah. It goes along with just piano or notes or anything, yeah.
I think we should move on to next, yeah? Is there any like urgent question? No? Okay. Who's next presenting? Everything is highly improvised here as usual. Not yet. No, it is, yeah. Somebody give us a presentation. Timo is going to show us something. Okay. We're going to set it up. 1 second. What do you Just for reference, this placeholder we're using is kind of a minimalist composition for an installation. This was presented in a new institute in the Architecture Museum here in Rotterdam about a year ago. This is Orca and MIDI. So you can see the MIDI notes on the right and the Orca code. Sort of an overlay of the Orca code on the left. You let us know when you're ready, Timo. Yeah, you are? Okay.
Wait,
You're
I
on.
probably should be more. I'm on. And I didn't check sound. Is this working? Yes. That's no. This is live pressing keys. Hi everybody. Yeah, for those who don't know me, my name is Timo. Timo Hoogland. And I thought it would be nice to show briefly some new features I've been working on in the live coding environment that I use and develop. It's called Mercury. Yeah, it has many similarities with Super Collider and Tidal Cycles and Sonic Pi, many other languages. And this, yeah, I've been working on this for a long time. I started doing this in 2018, and it's still not finished. So, and I'm not sure it will ever be, but in any case, it's very nice to keep developing things and finding new inspiration for sounds and inspiration for effects and music, etc. So, yeah. One new feature is that it actually finally has its own domain name. Yeah, it wasn't that difficult, I just had to pay money. But it's very nice to have that now finally on the web. Before it was already on the web, but it was on a different platform. Yeah, so this is what you'll see. And yeah, before I give like a whole tutorial on how to start, I thought I'll focus first on the new things, and then maybe if there's some questions, we can do some other things. But you're welcome to give it a try afterwards also, if you like. So the new features are some sound design features. And one of those is different sources for sound. So Johan was already showing some sources like sawtooths and waveforms, which are very nice if you want to make melodic music. But something that Mercury was really missing was actually noise. So this is one of the new features. So you can generate some white noise. And so this will give a little noise burst, as you can hear. I can make it a bit longer. Yeah, that's better? Okay. So this is some white noise. Well, for those of you who are familiar with types of noises, you might guess another one, pink noise, for example, which sounds more dark. Then there's some other types that are a bit more complicated, like for example Brownian noise, which has some different densities. And the cool thing is with this type of noise is that you can start sequencing this density in some interesting ways, and that will give you some nice rhythmic results. So basically the density kind of changes how dense the noise is, and the higher the value, the more bright the noise gets. Another type of noise is the lo-fi, which sounds more 8-bit. So different types of noises to play with, which could be nice to generate hi-hats or other types of rhythmical percussive sounds. And also could be nice as a starting point for other types of synthesis. So one other new feature that I've been quite interested in myself is the so-called car plus strong string synthesis. So car plus strong string synthesis is a so-called physical modeling technique where you try to emulate the plucking of a string. So if you would search that, maybe I'll open a car plus strong string synthesis. This is how you would write it if you're interested. And so basically what it does is you start with noise and then you feedback the noise through a delay line, and by giving it feedback with a very short delay you get a resonance, and that resonance results in a tone. So that tone can sound like a string. And this type of feedback delay is called a comb filter or a feedback comb filter. And so I have this effect here as well. So if I start with, this is the very short noise burst, and then if I put that through the car plus strong effect, then you hear this string sound. Right? It's a bit soft. I can change the parameters a bit. So this effect has many different parameters. It has the tone that you want to play. So it has different notes that you can put in, and then you can make a melody out of that. Maybe I'll play it a bit faster. So you get this melody out of it. And the second parameter is the amount of feedback, which results in how long the sound will resonate, basically. So now it's very short, and if I make this feedback closer to 1, then it creates a longer tone. And then there's a third parameter, and that parameter is the so-called the damping, which allows you to cut out higher frequencies faster, which will give the string more a dull sound. Right? So this is slightly different than the feedback. It still sounds short, but it goes still in the low frequency range. It resonates a bit longer. And the last parameter is the wet-dry. So that's not super interesting, but it's there. And so, yeah, all these parameters can be modulated, of course, so that could be nice to make melodies with. Maybe this one. So yeah, so that's the car plus strong effect. And something, actually, how am I on time? I don't know how long I am allowed to talk. So you just say stop at some point, and then I'll stop. You have a question? Yeah, of course. Oh,
Wait a
sorry.
minute.
I can also repeat the question in the microphone. That's.
So you're creating a noise, and then you're synthesizing that noise using the car plus strong method. Is that the case?
It's a bit of both. So I'm synthesizing the noise as well, and then this very short burst of noise goes through this car plus strong effect. So that's the feedback delay. So if I would look on this, so this part is the car plus strong effect, and this part is the noise burst, and that goes in it, and then it feedbacks, and then goes out to the speaker. So it's two steps basically.
I see, but it is already based on noises, like conceptually the car plus strong string synthesis is already based on
yes,
noises.
but I didn't want the noise as part of this effect because you can also use this effect on, for example, drum beats or something. So if I make this drum beat, I'm not sure how loud this is going to be.
Play it without, maybe first?
Ah, yeah, I'll play it without. Yeah, good idea. So this is the classic aim and break. I can put it softer also. Okay. But then I can use this in that instead as the noise as the impulse.
Okay, so this is what I was wondering, that can you use other input and what it would make
Exactly,
this
yeah,
is really
yeah.
cool. Thanks.
So it's an interesting effect to create also melody out of sounds that are not melodic out of themselves, for example. Yeah. So yeah, that's why it's as a separate effect. Yeah. Mm-hmm. Mm-hmm. So the noise is just an oscillator. Well, it's not an oscillator; it's a generator.
Yeah.
Because if it would be an oscillator, we would hear a tone. But the noise is just continuously generating noise, and there's an envelope on top of it. That's the shape that you see. This is a very short shape, 20 milliseconds. It sounds like this. If I would remove that, then we would just hear the whole time. I'm not going to do it because I don't like that for now, but it's possible. And then this is going into the effect, because the effect is the next thing in the line in this case. Yes. And the resonance of the feedback of the filter is the thing that creates the tone.
Yeah.
That gives it a tone because it has feedback, yeah, and therefore resonance. Yeah. If I would increase the delay of this, like if I go very low, let me remove all these extra parameters, it's a bit unclear. So now it's a very low note. But if you get even lower, it's just a delay. It's just a delay, right? You start to hear the individual bursts. But as soon as the delay gets shorter and shorter, and then the bursts come closer together, that's when you start to hear the tone or the frequency. That's how it works. Yeah, yeah. What else? Yeah. So this is one of the effects that I've been working on, and together with this white noise, I've been developing these because this is in the browser, as you can see, right? I've been diving a lot into the so-called audio worklet processor, not that thing. And this is basically, so if you want to develop sound for the web, you need to program that in JavaScript. And there's the web audio API, which allows you to already create sounds by combining nodes. But not all the types of sounds that you might want to create are available in the web audio API by default. So instead, you can write your own audio worklet processor, which allows you to basically program the sounds per sample. So this is, oh, I lost my visual, but there was some code. It's still there. So this, for example, shows a little for loop that generates actually white noise in this case. So this is an example of how you could generate white noise. Basically, you generate a random value between 0 and 1, you multiply it by 2, and you subtract 1, so you get random values between -1 and 1. Anyway, this is can be quite complex if you dive very deep into it, but it's allowed me to program all these different types of noises that I have been making here, but also, for example, this Karplus strong feedback delay, because you need a very short delay line, and that can be difficult to get with the regular web audio API. So something else that was also created with the web audio API is a very nice reverb. This is one that I didn't make myself, but I can share you the source code. And so this is based on the, so wait, if I can also put this into the drum loop, of course. Let's use the game. We can also put it completely just 100% reverb, or much shorter. So this is based on the Toro reverb algorithm. I'm writing this wrong. I think it's with 1T. No, it's with double T. But if I type it with 1T, I get the paper in the first hit. Anyway, this is also based on this Carplus-Strong effect. Well, not necessarily Carplus-Strong solo, but in combination with other types of comb filter effects. So it's an algorithmic reverb in the sense that for every sample that goes in, it calculates all of everything needed to get this reverb at the output. And it is interesting because it sounds very good. It is a bit expensive for the CPU compared to the standard reverb that they use in the browser, which is a so-called convolution-based reverb. But in return, you get a reverb that sounds very good. So I prefer that. And since computers and the browser is getting better and better, you can use it. It's not that big of a deal. But as soon as you have 20 instruments, everything with its own reverb, then it could be quite heavy at some point. Yeah. You want to intervene?
Yeah, just a question about this. So can you make the reverb global in Mercury or?
Ooh, nice glitches.
Yes.
No, in the way Mercury is designed, you give a reverb to every instrument individually currently. Maybe I'll make a kind of like a bus structure in the future. But so yeah, every instrument that you make, if I do this, or if I put some other some synthesizer here and I say effect reverb, then everything gets its own reverb. Yes, so this is already 3 of those reverbs.
Cool.
But so this whole reverb was also implemented with this web audio workload processor. I can find the link, probably, the Toro reverb. JS, I think it's this one. Yeah, so this is, I mean, it's much more code than this little white noise processor, as you can imagine. But I learned a lot reading this as well.
Very cool.
Very good.
Super
Yeah.
cool. Maybe I think we should move on to
Yeah,
Dennis,
of course.
but maybe if there's one more question before we move on to the next presentation. Anyone?
Or
Okay, it's open to consensus. There's one question.
one
from
small
Johan.
question. Tell me.
If you put 10 reverbs in your processor, if you put too many reverbs in and your processor is struggling, how would you notice that when you are playing?
You notice the processor is struggling when you hear sample dropouts in your sound. When it sounds to start like, then that's the moment when it's too much.
That
yes.
then you know.
Yeah, but just to have a little, what's happening with the HDMI? Interesting. Somebody take a picture quickly. It's me. Yes, got it. I thought maybe I'll click some example.
Maybe you
let's
have
see.
too many reverbs, I'm not sure.
What's happening? Okay, so this has quite some instruments, but I think I can give everything a reverb, and then it's probably still okay. Yeah, this is 1, 2, 3, 4 instruments with a reverb. Yeah, but typing this gives everything an individual reverb. So you don't save any resources by doing this. It is just less typing, but it's not less processing. Yeah. Yes. But I can put this, I can give it an extra reverb, so we can make a chain of reverbs.
So the question is about the you can no, this doesn't give you a global reverb, but it gives you mixed parameters global, and now it's a reverb.
Yeah, exactly.
Mercury retrograde. Mercury retrograde.
Okay, this is too much. I'm gonna do this. Okay. But yeah, so
Beautiful.
it's still good after so many reverbs, it seems. So
Great job.
the
Good
computer can
stuff.
handle it.
Yes.
Thank you. All right.
Okay, so let's take Nikki's advice. Let's make a short break, and then we have a presentation from Dennis, and then we move on to Jams. Ben? Yeah, okay. So then we do the break, and then we do these two shorter presentations. Yeah, great. Let's, okay, let's go.
There's a little plug in between. Some background music. Just I click example, and then we use that. Okay, right. This can just continue.
hello, 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 hello. Not yet, not yet. Hello, 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 hello. Hello. We are back. We're back. We're back. Okay. We're back and we have like two more presentations. Ben has a super short presentation. Would you like to go first, Ben? Dennis gonna go first. Is that how? Okay, so Dennis is gonna show us some news on Strudel, and here's your cable, and here we go. So, and audio, no problem. We have a placeholder, abstract, spooky abstract music while we wait for Dennis to connect. And Ben, you're gonna show P5? Okay, great. Yeah. Touchpad on Hydra. Dennis is ready. You wanna give me some sounds just to check if you have. Almost there. Yep. Okay. It's coming. Almost there. Yeah. I hear a click. Ah. Hello. Great news. We have some technical problems. Maybe your audio MIDI setup. Yes.
Every team had a chance if Steph's Robin.
This is
That's
your
my
machine.
Batman and I don't know who else.
And nothing coming through now. Okay. Yeah. There we go. Now we did lose your screen though. Right, here we are. Okay, I cancel myself and I give you the microphone.
Yes. Okay. Oh, nice. Hello. My name is Dan. Today I will show something, some news that was been in Strudel. It's a live coding environment that now is used by many social media people. But it's not that it's better or anything else. It's just became very popular last year, and I like hype, so I also jump on it. So it's now has a lot of contributors in their repository that is like people adding a lot of stuff every day, and it's hard to review for administrators. So, but slowly they adding some interesting things to it, and I wanted to show if people are using Strudel, so they can see what's new happened for the last 2 maybe months. That was merged, I would say, in the production. And I think the first one that you can see, it's an import pre-bake script. In the settings, if you go to settings and then go here, you see it's like a possibility to add your script or like custom functions that you can use and be really efficient with your code. That's yeah. Before I think you has to write everything like this, like function, and then you just write a lot of stuff before, and then like this. But now you don't need to do it, and you just write some script in JS, and then import it as a samples, and then it will be every time used. I think maybe no, in this environment I don't have, but yeah, you can do it. That's from settings. Then there is like also interesting setting, I think this enable tooltips on control, and so now you can always move it and tap control, and it will show what does it mean. So it's very useful when you don't know what you're writing, so that's good. And yeah, and then the fun thing that they added, I think it's a distortion. So now you have, oh, let me also, I don't know what to do. Yeah, auto-completion, yes. So now you can use distort type. Let's see what type they have. They have like a fold different name. I don't know what they changed. Maybe they like the algorithm of how they create distortion is. But you can also like sequence from them and like write different patterns. And yeah, let's try like a diode. And then maybe one, and see how it will change. Let's try another one. Which one? Fold. Let's see, fold. And diode. So yes, it's this one. Also, they added interesting thing like how it's called? Wait a second. Replicate that will speed up the pattern, and also will play everything 2 times. So if I write 2, it will speed up the pattern to 2, and also will play, I think, every note, every element in the pattern 2 times. Maybe not. So yeah, I don't know. Maybe it works with. I don't know why it doesn't play it 2 times. Replicate, but maybe we need like this to do, so it will work. No. Okay, so they added it, but yeah, they said that it's like increases the step count accordingly, but it's not really sound like I expected. Yes, also they added some modulations to frequency modulation. So before it was like, I think, only 2 parameters, frequency index and frequency ratio. Let me add also a node. Minor. Yeah. A little bit editing, so it wouldn't be so. So yes, now like you can just change these 2 parameters, like frequency harmonic frequency ratios that create more like sound harmonic. If you use like integers, like beautiful numbers, if you use ugly numbers, then it will be not nice. I mean, like 1 and 7, it's ugly a number, right? So you see, but if you use 2, yeah, it's more pleasant sound creates. And then just a frequency, index. It's as well like brightness to edit, right? So there was 2 sounds, but now we can also add a frequency wave. So it's like a waveform of modulator, and let's use a square, for instance. I don't know. Okay, let's use a super saw. Square triangle. So yes, now you have waves, so you can modulate with waves. It's more proper one, I think. And also interesting thing that I think we can mention that they added low pass filters, but not just a low pass filter, but also low pass sync, not low pass rate, low pass filter rate, low pass rate. Yes, so it's not just adding filter, but it will create a modulation, like a filter modulation, and it will sound like. Oh, can you hear me? Yeah, it's strange something. No, it's not like this. Maybe we need to add more sounds, like not. We will add slow 4, and then we will add. Yeah, I think so. Let me just put it. I think it's also, I really cut filters, so yes, it will be gain 0.3, for instance, and then we add like here 0.5. Yeah. Let me try this. The tune. And now let's try again. Okay, and then. Yeah, make it high. Oh yeah, it become a little bit like whoa, 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 like this. I don't know. Let's do it. Set CPM like. So yeah, it creates some kind of vibration for the sound. That was added. Very cool advanced feature. Yes, and what else maybe to add? Distortion modes, yes. So yeah, I think that's it. That's what they added. Not so much, but still something.
Great. We're quite short in time, but still, if there are some questions, maybe for Dennis, anyone? Questions about Strudel for Dennis?
Nobody.
No? Okay. Then Ben, maybe we can move on. Thanks, man. It was great. Thank you. Okay. Placeholder, ghostly music. Here we are. Okay.
Okay, so
This is still a work in progress from our last meetup that we did in Den Haag. So I don't know if you know this, but your Mac trackpad tracks a lot of data on your touches. It tracks your pressure, how many fingers, the average angle of each finger, the pressure of each finger on the trackpad. There's a lot of data there. Until recently, it was not exposed to the public, but there are some public open source libraries that expose this. We had an idea to take one of these libraries and transform it into some sort of live coded environment. This is a very hacky, janky, work in progress version of this. What this does is there's a few servers running in the background. They are using these open source libraries to track all of the fingers and all the touches out of it. And then we are porting this into Hydra. If you don't know Hydra, Hydra is a visual live coding environment that is very much influenced or inspired by visual synthesizers from the 1970s. It's very, very cool. And now we can do, running all these libraries, this is very, very fast, we can change things with just a tap or a pressure. There's a few things here that's running in the background. You see here, I'm forwarding this with the UDP client. And as you can see here, it takes how many fingers I'm holding, how many fingers I'm touching. This can take more than 10 fingers, apparently. We tried a few hands. It is incredibly accurate, the amount of data that the Mac trackpad takes. It is very, very nice. Here, for this Hydra example, as you can see, there is this arrow function. And I've exposed here just a few things: the average X position, the average Y position, the average pressure, what finger is touching, like what number of fingers. So for here, like I'm doing just finger 0, so it's like the first finger, I can do whatever. And also the average pressure that controls color, the rotation, the scale. So just like moving on the screen and changing the pressure, the number of fingers, I get a lot of like crazy things. Right now, it's working in Hydra. Hopefully, when I have time, it will work in P5 Live. Maybe in Strudel? I don't know, we can try. Yeah, that's it. That was a very fast introduction. Unfortunately, half of this is vibe coded because the library is written in Swift and I don't know Swift. So the Swift part, unfortunately, Cloud Code took care of it. The JavaScript, I kind of janked it up myself after we finished the last meetup. But that's it. Hopefully, in the jams, I'm gonna get to use this a bit. Yeah. We can do.
Can I also use it during the jam? Can I use it on your laptop during the jam?
Yeah, sure.
I want to try it out.
Yeah, sure. Yeah. All right.
A question from Timo. One moment.
Yeah. Oh, I will put in the HackMD the repos, the open source repos that we use as a basis for this if everyone want to replicate. Yeah.
Maybe I missed it, but how are you forwarding the data from the computer to Hydra? Because this is running in the web.
There's a WebSocket. So you see there's an NPM here that's running this in UDP, and there's a WebSocket on localhost something. Yeah, the web basically.
But how is it entering into the Hydra site then? Because that's running on a different server, right? How's that?
From WebSocket from Chrome. So there's a code here, a lot of code here that grabs this from my WebSocket, from my WebSocket, into the Chrome, and then there's a function that feeds it into as an arrow function. Because in Hydra, you can write your own JavaScript.
Yeah, exactly.
So basically, I am getting this from here.
Yeah, so you
right.
So you are running a local host.
Yes, I'm running a local host
for this data.
Exactly, and then I'm writing this code to have Hydra pull this data from my WebSocket.
I see.
Basically, I'm sending this to WebSocket and then pulling this from, like forcing Hydra to pull this. That's why it's so janky.
Yeah, but still interesting.
Yeah. It will be.
And this code is also on the GitHub somewhere?
No,
or
this is not. I can send you it's a private repo for me. I can send you this and you can try.
Yeah, or
and work
just
with this.
if you copy paste that in Signal is also fine.
Oh yeah, I can.
You
But you
check.
do need to run. You see, there's an npm.
Yeah, no,
running.
I'm actually mainly interested in the OSC data sending.
Oh yeah, it's
for
OSC
for
basically.
other applications as well.
Okay,
not
so
only.
I'll just send you the repo because it is sending this in OSC basically.
Okay,
Yeah.
okay.
It's a multi-touch. It's OSC. The OSC part is written in Swift, and that's Cloud Code because I do not know Swift. But basically, the WebSocket is sending it in OSC.
Yeah, and I'm interested in the WebSocket part,
So
that
just send it-
JavaScript part.
So I'll
yeah,
just send it to you.
yeah.
Okay.
Cool. Yes, thank you.
Awesome. I'll just give it to you. No problem.
Any more questions? Anyone?
What?
Okay.
Where's my mouse? Oh,
Very
here.
nice. I like it.
Yeah, thanks.
Yeah.
All right,
Thank
cool. Thanks.
you, Ben. Thanks a lot. Okay, let's have a short break and then we do some jams if people are up for it. The jam format is the classic from scratch, 9 minutes from scratch. And okay, we'll set up some pairs here. And in the meantime, we have a drink. Okay, so we go for a break. Hello, 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 hello. We are slowly moving back. This is too loud. Yeah. So we're going back, and Timo's gonna go first, and you're gonna go first with Timo. Okay. Then Rick and Timo are gonna be number one. I'm going to stop this microphone. Okay, so we're gonna start jams, and we're gonna do 9 minutes. And minute 9, I'm going to, we're going to upload, and that's gonna be the end of it. And then the first slot, the people that jumped in first were Timo and Rick, and then next is gonna be Johan. Maybe Uniki wanna go next? Yeah, because in the meantime he jumped in. So then it's going to be Johan and Nikki. But for now, let's go with Timo and Rick. And yeah, I'll keep it track of time. Yes. So we go. Yes. Thank you. That was great. Short changeover. Yes. Okay, change over. Thank you. That's Johan and Nikki. And I'm not sure who's next, but we're going to change over now. Change over. There was Dennis and Denry and Erie. Who's next? That was it. Thank you, everybody. Thanks everyone who were here, everybody that came here, everybody who joined online, and we have coming up next Friday on the 20th. This Friday, 20th, in Amsterdam, Vondelbunker, yeah, in the Vondelpark. And our next meetup is anyone remembers the date? No, nobody remembers. Somewhere next month. The beginning, early next month, we have another meetup here at V2. So hopefully see some familiar faces and new faces as usual. Thanks everyone. This was number 16. Thank you.